Hey, what's going on YouTube? This is Arunava. In this video, we're going to talk about scopes in Python and the LEGB rule. And I'm going to assume a basic familiar with Python syntax. And with that, let's get started. One of the things I love about programming videos is speed typing. Let me show you some. I feel good. Now, let's look at an image. So this is what LEGB stands for: local, enclosed, global, and built-in. And just notice the arrows. You will understand what this image is all about by the end of this video. And I'm going to keep this image in its small form on the screen so that you can look at it whenever you want. Alright, let's look at the code I just speed typed. So you open up a Python script and start typing. Whatever variables and functions you have declared at the zero indentation level, these are the variables that are said to be in the global scope. So this A, this B, C, and D, and this function func, these are the variables that are said to be in the global scope. So cool, this gives you intuitive feel of what a local scope should be, right? Okay, speaking of local scopes, let's look at the body of the func. So this A, B, and C are the variables that are declared to be in the local scope of this function func. So the variables A, B, and C in the global scope are different from the variables A, B, and C in the local scope of this function func. Now, note, if you have a different function, it has its own local scope. So the variable A in global and the variable A in the function diff and the variable A in the function func are all different. So this scope is local to the function func and this scope is local to the function diff. Okay, let's run the program and see. So Control Shift B, and let me just open this up in a new tab, and let me split this tab to the right so that you can refer to this program as and when you want. Okay, you can see when func is called, the values A, B, C in the local scope of func are printed out, and for the variable D, it prints the value in the global scope since no variable D is present in the local scope of func. And for the function diff, it prints out the value of A, which is local to the function diff. Okay, let's look at this line for a moment, and we can say that Python looks for the variable D in the local scope first, and when it doesn't find any, it looks for the variable in the global scope where it finds D, and thus it prints the value of D from the global scope. Okay, after this func, the values A, B, C, and D in the global scope are printed out. So Python looks for these variables in the global scope where it finds them over here and prints them out. So adding a line like say E would result in an error. So if you just run it, and that's the previous result, and there we go, the error, because no such variable was found in the global scope. Note, I deliberately chose to call func before printing out the global variables to make you understand that declaring new values to A, B, and C in the local scope of func doesn't change the values with the same variable name in the global scope, since they're different, as I said. Now, let's have a function inside the func function called inner and rename the function func to outer just to make life easy. Alright, want to speed things up? Cool, now we have variables A in the inner function, and when we print this out, there you go, here it is, inner of 32. So when we print this out, Python looks for the variables in the local scope of the inner function, and for the ones not present in the local scope of inner are searched for in the enclosed scope of inner, that is in the case of E. So E is not present in the function inner, so it's searched for in the enclosed scope of the function inner, and hence 9 should be printed. There you go. And for the ones not found in the enclosed scope are searched for in the global. So you can see an example like D, right? Note, I just used the term enclosed scope without explaining it beforehand, but it is quite intuitive. Since the outer function is enclosing the inner function, we are calling the scope of the outer function as the enclosed scope of the inner function. It boils down to this: a variable used in an inner function is searched for in the local scope. If not found, it is searched for in the enclosed scope. If not found, then it is searched for in the global scope. And if not found in the global scope, then it is searched for in the built-in scope. So what's the built-in scope? It's just a handful of useful functions and special keywords that Python reserves for itself to make life of a programmer simple. An example would be simply to use the sum function built into Python. Okay, so with all the speed, you might be getting a bit dizzy, so I'm gonna type this normally. Screw your dizziness, man. I love to speed type. Good stuff. All right, if you run this, and I'm gonna keep this in a new tab. Okay, so this prints out the sum, and no sum is declared in the global scope. So it looks in the built-in scope and finds the sum function in the built-in scope. Now, if you rename the sum to function over here to sum and then run it, there you go. So I'm gonna again do the same thing over here and split it to the right. Okay, and close this one. So you can see that it prints out the print statements present in the sum function in the global scope, right? So if it first looks for the sum in the global scope, and then if not found, it looks for it in the built-in scope. And good, here's the image. Take a look at it. So variables are first searched for in the local scope, then if not found in the local scope, then it is searched for in the enclosing scope, and if not found in the enclosed scope, then it is searched for in the global scope, and if not found in the global scope, then it is searched for in the built-in scope. All right, and if not found in the built-in scope, you will get error, my friend. All right, so congratulations, you now know about the LEGB rule in Python. Good. Let's now quickly look at two built-in keywords in Python, global and non-local. Okay, let's see an example. So you need the global keyword to declare that a variable inside a function is global. That's simple. So as you declared in the function that a is global, so now this a and this a in the global are the same, and changing the value of a inside the function would also change the value of a outside the function that is in the global. So if I now run this function, then you can see that it prints 56 from the function and 56 from global. That is, the value of a was 5 here, and then over here demo global function is called. So demo global says that it is accessing the global value, the global variable a, and it's changing its value to 56. So and then it's printing the value the value of a, which is 56 over here, as you can see. And then after this, when the value of a in the global is also 56, as you can see, it's printed out over here. All right, now moving on to the non-local keyword. So let's now run this program and let's see its output. So before talking about the output, let me just say something, that this non-local keyword is very similar to the global keyword, as you can guess probably. So non-local is used in a nested function to declare that a variable is not local to it, and thus the variable belongs to the enclosed scope. Also, changing the value of the variable inside the inner function over here after declaring it as non-local would also change the value in its enclosed scope, as you can see in this example. So over here, so b is not printed over here, so we can just go ahead and add that over here, change it to b, and then run it. So over here b is declared as 45, and then this demo non-local function is called. So and demo non-local says that it's accessing the non-local b variable and changing it to 90. So b from non-local is 90, and then from function a is 56, the first one over here, and then the b is 90. As you can see, it's changed from 45 to 90. As I said, and the demo non-local function accesses the b in the enclosed scope and changes its value. All right, so that's all about global and non-local. Good, you now know about scopes in Python and the LEGB rule. If you like the video, do show your support by giving it a thumbs up and sharing it. It would mean a lot. So bye bye, take care, and have an awesome day ahead. See y'all next time.